Okay, so the next bit, when it says the rate of change, so rate of change, remember, is derivatives. So at A, the rate of change at A would be 0, because we know that at any maximum or minimum point, the derivative is 0. So here, the key thing is that rate of change indicates we're talking about derivatives, and so therefore it would be 0. It's only worth 1 mark, so you don't need to give any more information. Find the coordinates of B. Okay, so what's B? So B is the point of inflection. So I would suggest that the easiest thing here is we know that points of inflection, point of inflection have a second derivative equal to 0. So the second derivative, sorry, I'm trying to find, all right, so we've got negative 6x squared plus 6 is equal to 0. Hang on, do we already have that? Oh, sorry, I had a big break, so I thought you knew this bit already. Okay, let's find the first derivative. So the first derivative, let's do it here so we can see it. So f dash x would be, I'm sure we have done this, 2x cubed plus 6x. Yeah, and then so the second derivative would be negative 6x squared plus 6. Okay, so negative 6x squared plus 6. So negative 6x squared plus 6 is equal to 0. So negative 6x squared equals negative 6. So x squared equals 1. So that means x equals plus or minus 1. Well, looking at the diagram, this value here must be positive 1. Okay, so that means that x is 1. So x is 1, and that would make y, when we stick 1 into here. So keep remembering it. So we've got negative 0.5 times 1 times 4 plus 3 times 1 squared plus 2 times 1. So that's negative 0.5 plus 3 plus 2, 5, so that's 4.5. So the coordinates are 1, 4.5. Okay, so we've established, so A we worked out to be, oh god, I can't remember, what was it? A was 1.88 and B was 1. Okay, and we're talking about the volume of revolution, so remember that's the integral of the function 0.5 x to the 4 plus 3x squared plus 2x all squared between 1.88 and 1. Okay, so notice I've written that down, oh god, from the question, but it's on paper 2, so it's on the calculated paper, so we can use our calculator to do it. So I think I've got my calc now. Right, so let's look at this. So we're doing math 9. Our numbers are 1.88 and 1. Now I'm opening up a bracket because remember we have to square this function. So it's negative 0.5 x to the power 4 plus 3x. Oh no, what have I done? Plus 3x squared plus 2x close brackets squared. Okay, so that's the function squared dx x between those two numbers. Okay, enter. Oh, and remember there's pi, so it's, oh, let's snip this. Snip. So it's going to be this, so it's going to be 41.067587 multiplied by pi, because it's pi fx squared. So multiplied by pi gives us 129.01. Oh, let's snip that as well. So that's our answer. So to 3 sig fig, it's 129. Okay, and next one. All right, so we've got two functions. So I would suggest to plot those babies. So x squared plus 1 and negative x squared negative x squared minus 2x. Minus 2x plus 5. Okay, window, oops, go standard. Okay, so there's our two graphs, and we want to find this area here. So first of all, we need to know what these two values are. So window, no, what am I doing window? Second calc, intersect. So, oh. So here it's at 1, 2. That's where they meet, and then we need to do that again. Calc intersect. We'll shift it over to nearer this one. Enter, enter. So this is negative 2, 5. And so remember, it's also important that we check to see whether any of it's below the graph. It's not, it's all above the graph. So then we are finding the integral between 1 and negative 2 of the red function subtract the blue one. Okay, so the red function is negative x squared minus 2x plus 5 subtract the other one. Was it x squared plus 1? X squared plus 1. Again, it's on the calc paper, so you can just chuck it in the calculator. We just need to establish what our two values were. So math 9. Oh, let's clear all this stuff. So math 9. So between negative, what was it? Negative, oh gosh, already. Gosh, negative 2. Negative 2 and 1. So we've got negative x squared minus 2x plus 5, subtract, open the bracket, x squared plus 1, close bracket, dx. So this says it's 9. The mark scheme has something crazy. So I don't know what's gone wrong. It says they've got 0.538. So not sure what's happened there. I'll have to look at that again. Right. This final question, it changed. Okay, so the first one, so we're going to be remembering that we treat it as though it's a normal expression. So it's 3x minus 2. We add 1 to the power, divide by its new power, and then we also have to divide by the derivative of what's inside, so that's 3. So that would be 3x minus 2 power 7. Oh shoot, 9, sorry, add 1, can't read my writing, over 27 plus c. Okay, and then this one here. So this is our main expression, so this is x cubed minus x squared to the power of half. This is already there. Okay, so if we focus on this left-hand side, if we integrate that, it would be x cubed minus x squared to the power 3 over 2, divided by 3 over 2, but also divided by the derivative of what's inside, so that's 3x squared minus 2x. And lo and behold, these two here cancel each other out. So we've just got this bracket here divided by 3 over 2. When we divide by a fraction, we multiply by its reciprocal. So that becomes x to the 3 x squared to the power 3 over 2 plus c. So there we go. Alright, so I just need to double check on that number 6. I don't know what happened, but I want to post this so you can have a look at it now. Okay, bye.